About 66 million years ago, the 15-kilometer-wide Chicxulub asteroid wiped out 75% of all living things on Earth in a very short time, leaving a 180-kilometer-wide trench off the Yucatán Peninsula. Researchers now believe it didn't act alone. In the newly discovered Nadir crater off the coast of Africa, traces indicate a potentially even more massive event than previously thought. What exactly did scientists find there? And how is the impact from Africa related to the great dinosaur extinction? Stay tuned until the end of this video to explore Earth's past and discover the likelihood of such an event happening again in the near future. In a matter of minutes, the Earth's fate was sealed. When the Chicxulub asteroid struck our planet, the inhabitants of that ancient world likely saw a blinding light for mere moments before the cataclysm unfolded. Within seconds and minutes, life as they knew it was irrevocably altered. The impact unleashed a devastating force that obliterated all life in its immediate vicinity within moments. The shockwave rippled out for hundreds of kilometers, rupturing the Earth's crust, igniting infernal fires, and releasing toxic gases into the atmosphere. It ejected massive volumes of rock material into the skies, plunging the ocean floor into turmoil and unleashing a colossal tidal wave to compound the chaos. This catastrophic impact likely triggered a global mass extinction event, ushering in a series of profound climatic changes. The darkening of the atmosphere and the ensuing cold temperatures spelled doom for life on Earth. Initially, it was the plants that withered away, followed by the creatures that depended on them, and eventually even the carnivores met their demise. This event marks one of the 5 known mass extinctions in Earth's history. The first of these cataclysms occurred at the end of the Ordovician era around 443 million years ago, erasing 85% of marine species, possibly due to a combination of climate change and celestial impacts. A similar scenario unfolded during the Lake Devonian, resulting in the demise of 75% of species. The most devastating mass extinctions, however, occurred around 252 million years ago at the end of the Permian period and approximately 201 million years ago during the Triassic-Jurassic transition. These events were caused by massive volcanic activity and the subsequent climate upheavals, leading to the disappearance of about 96% of marine species and 70% of terrestrial vertebrates. The most recent addition to this list was the Chicxulub asteroid impact, and it is highly likely that it was not alone. Recent discoveries have unveiled a new crater off the coast of Africa, the Nadir crater, which is approximately 66 million years old and thus contemporaneous with the catastrophic impact in Mexico. The Nadir crater first piqued researchers' interest when aerial photographs of the Yucatán Peninsula in the 1970s revealed its presence. Subsequent investigations in the 1980s confirmed that only a colossal impact could have formed such a crater, aligning perfectly with the timing of the mass extinction event that wiped out the dinosaurs. Geologists and paleontologists quickly connected the dots. However, the recent revelation of the Nadir crater off the African coast has challenged the notion that the Chicxulub impact was the sole perpetrator. Originally, scientists were studying seafloor spreading processes, which played a role in the formation of the Atlantic Ocean by pushing apart the African and American continents. Unexpectedly, their data revealed an 8.5-kilometer-wide depression beneath the seafloor, featuring a circular shape, a raised ridge, and a prominent central bump. Furthermore, it exhibited signs of chaotic sedimentary deposits extending for kilometers beyond the crater. While craters on Earth can form through various mechanisms, such as volcanic collapse or salt mining, the characteristics of the Nadir crater strongly suggested an impact origin. Situated about 350 kilometers off the African coasts of Guinea and Guinea-Bissau, this relatively small, 9-kilometer-wide crater lies under 300 to 400 meters of marine sediment. Despite its smaller size compared to Chicxulub, the Nadir impact must have had devastating consequences. With an estimated age of 66 million years, it closely aligns with the Chicxulub event. Through computer simulations, scientists have gained insights into how the crater formed. The impacting object, roughly 400 meters in diameter, struck at a depth of 500 to 800 meters in the ocean, triggering regional devastation. It generated a magnitude 6.5 earthquake and unleashed a tsunami of up to 900 meters in height, wreaking havoc across the Americas, Northern Europe, and even reaching Antarctica. While the energy released by Nadir's impact was smaller than Chicxulub's, the resulting tsunami was thousands of times more powerful than the one caused by the Hunga Tonga Hunga Hapai volcano eruption in 2022. Researchers now hypothesize a connection between the African and Mexican impacts. Large asteroids like Chicxulub often have smaller companions, and it is plausible that the Nadir impactor was one such moon of the Chicxulub asteroid. Another possibility is that the colossal parent asteroid fragmented into multiple pieces, following a collision with a larger celestial body. While such events are likely rare, they do occur, as evidenced by the discovery of double impact traces in Sweden about 470 million years ago, resulting in the Loch Ness and Mellingen craters. Adding to the intrigue is the Bolatash crater in Ukraine, discovered in 1996. This 24-kilometer-wide crater's age, approximately 65.4 million years, aligns with the Chicxulub and Nadir impacts. It is conceivable that these impacts were part of a series triggered by celestial turmoil in the main asteroid belt between Mars and Jupiter, causing multiple asteroid fragments to be hurled toward Earth. The impacts likely induced tsunamis in the Baltic and North Seas, fires, and global climate shifts that profoundly influenced life's evolution. So, when might the next significant asteroid strike occur? Given the historical record and current observations, it's a question that piques curiosity. On average, Earth faces the threat of collisions with asteroids or comets around 50 meters in diameter roughly every 900 years. More massive impactors, those exceeding 1 kilometer in size and capable of causing global catastrophes, strike on average every 100 million years. One of the more recent major impacts occurred over a century ago, when a massive explosion rocked Tunguska, Siberia, in 1908. While the remote location limited eyewitness accounts, the extensive forest destruction suggests an asteroid impact, leveling thousands of square kilometers of woodland. Despite these known impact events, there may have been others that remain undiscovered, particularly those occurring in the vast oceans, where evidence is harder to detect. Today, organizations like NASA continuously monitor near-Earth objects and main belt asteroids, offering some assurance that we are aware of potential threats. Most known near-Earth asteroids, fortunately, do not currently pose immediate dangers, as they are classified as potentially hazardous based on criteria such as size and proximity to Earth. For instance, Apophis, a notable asteroid, is projected to make close approaches to Earth in the coming decades. However, current calculations indicate no imminent threat of impact within the next century. Similarly, Bennu, another asteroid in Earth's vicinity, is closely monitored but not anticipated to collide with our planet in the foreseeable future. Advances in technology have bolstered our ability to detect and track potentially hazardous celestial bodies. Should an emergency arise, we have developed strategies to divert such objects from collision courses, offering a measure of protection. The solar system has become considerably more tranquil since the tumultuous impacts of 66 million years ago. In the early days of the solar system, Earth endured more frequent asteroid and comet strikes. Yet today, many of these objects are safely contained within the asteroid belt between Mars and Jupiter, or the Kuiper belt at the solar system's edge. Nonetheless, history has shown that we can never be entirely shielded from surprises. Smaller asteroid impacts have occurred in recent years, such as one over Greenland and the Chelyabinsk explosion over Russia in 2013. While these events are less conspicuous, they serve as stark reminders of the potential threats posed by smaller celestial bodies. Continuous advancements in monitoring and research offer hope that we will further enhance our understanding and preparedness for potential impacts in the future. What are your current thoughts? Is our safety assured on Earth? Or should we anticipate unexpected cosmic events in the future? Feel free to express your thoughts and viewpoints. And be sure to join the Revel Discovery community by hitting that subscribe button to stay up to date with lunar revelations and the forthcoming frontier of space exploration. Remember, as we venture into the universe, the sky is not the limit, it's just the beginning. Keep looking up,